Hi, um, my name is Giri Venkatesan. I'm a developer advocate at Solace. And the topic for my session today is asynchronous APIs and context mesh for real-time GenAI and agentic AI systems. Right? GenAI is at the peak of the hype cycle. Not true anymore. The case in point is, GenAI role is expanding. In Gartner's hype cycle, we can see the various emerging aspects of AI coming into play. GenAI, once hyped for the content creation, it now supports real-world applications in automation, simulation, and augmenting decision-making processes. Right? I want to focus on four key items here. At the innovation stage, we have multi-agent systems that allows for collaborative outcome from multiple independent and autonomous agents, enabling enterprise systems to handle more complex tasks, improving operational efficiency, and so on. Right? And then the other one is composite AI. It's nothing but the ability to integrate multiple AI techniques to help enterprises improve accuracy. And the new kid on the block, which is in the, I wouldn't say new kid, the peak of inflated expectation is edge AI. It allows for real-time processing and processing at the edges. Right? That's where event-driven architecture plays a major role. And in the big picture, generative AI's role is expanding. It allows for integration with the multi-agent systems, composite AI, and edge AI in enterprise use cases for better decision making. So it is not in the hype mode anymore. Some of these things are making a difference today. And it all started with the LLM, a pre-trained model serving a query without any real-time context. And an example would be the ChatGPT, which we all know, right? And then came the RAG, retrieval augmented generation. Basically combines the LLM power with external data sources to enhance accuracy and provide up-to-date context-aware responses. It is great. And then came, we are moving towards an agentic AI, which includes autonomous AI agents, multiple AI agents, right, that can interact with each other in the environment, the users, and so on to achieve a common goal. Autonomy is the key, and shared outcome to achieve the goal is a path to success, right? It's useful for orchestration, workflow automation, and complex decision-making scenarios such as virtual assistant, handling end-to-end business processes, and so on. Okay? So when we are talking about AI, what does Solace offer? First of all, what is Solace, right? Solace PubSub Plus platform is a complete event streaming and management solution for building event-driven architecture, right? I'm going to focus on two key components: an event broker, a real-time event distribution engine that supports multiple protocols from MQTT, JMS, REST, and more, and many more, and an event mesh, a scalable solution that connects in event brokers across environments, enabling a seamless event flow across the network. Right? It works across cloud, on-prem, and IoT environments. But that's about the Solace Plus platform. The world interacts with everything via APIs, no different for EDA, right? The event-driven architecture or the event-driven systems exposes its intricacies and functionality as event-driven APIs, which is also referred to as asynchronous API. According to Gartner, this definition simplifies this. Event-driven APIs are a new style of API that uses subscription, a push-based model rather than the traditional request-response model for conventional RESTful APIs. Right? And the second point I want to touch upon is the notion of event mesh, right? That's Solace PubSub Plus platform capability. It is the foundation for modern enterprise, comprising a network of interconnected brokers offering you smart routing of events, edge fan out, guaranteed delivery, network optimization, and so on. Okay? So this is the key for a scalable, federated setup where information flow, real-time information flow seamlessly. So at this context, we should kind of bring in the AI into the picture. That's where we have this term context mesh. What is a context mesh? Context mesh builds on an event mesh, basically the network of interconnected brokers that we discussed, to route information across applications and devices globally in a real time. Okay. It enhances the event mesh by incorporating AI agents. These AI agents provide real-time context to the data being exchanged, enabling more intelligent decision making and responses across the network. Okay. The role of EA and event mesh in an AI context, right? So the Gen AI, we know what it does. It digitizes the real-world events by leveraging event-driven architecture, turning physical stimuli into actionable digital insights, right? So example could be a user interaction, sensor rating, environmental changes, and so on, right? And Edge AI refers to the deployment of AI algorithms directly at the edge of the network. In this case, we're talking about the event mesh, rather than relying on a centralized setup. This allows for quicker data processing and decision making. Then comes the multi-agent system. It can leverage EDA and event mesh to share data and collaborate across distributed systems very efficiently. Okay? Of course, AI has challenges, and let's look at how EDA comes in to rescue, mitigate some of these challenges. What you see here is a lack of real-time context, fragility in AI applications and POCs, limited capability of one model approach, over-engineered AI agent. These are some of the issues, right? So if you look at the lack of real-time context, that's a serious problem, right? The data exists either in a siloed manner, or it exists in a distributed set, right? It limits the AI's ability to operate with real-time context because it's missing. The solution is to stream real-time events to the edges via event mesh, so that the up-to-date actionable information can be routed across the systems, right? That's where the EDA and event mesh comes in handy. And then the AI applications and POCs, as they are being built, the environment in which it's operating is rapidly evolving, and the components continues to change, right? So that means it needs the ability to adapt to the changes. That's where the enterprise-grade EDA and the PubSub mechanism comes into play. It creates a resilient, scalable AI system. When you combine AI and the EDA with event mesh. Okay. And relying on a single LLM model is insufficient because our needs are diverse. Every task or all the tasks that we expect the AI to operate upon requires different capabilities. The solution is to use composite AI through an event mesh, allowing specialized models to collaborate and share context in real time. Okay. These are other genuine problem. Current agentic frameworks are monolithic and often ends up in creating over-engineered AI agents, almost like a black box. Now, the solution is to leverage the smart topics functionality of Solace EDA to create more transparent, observable, and context-aware AI systems. Okay? So you can find more information about the smart topics in our solace.com. This is a central capability of our Solace EDA. Now, how does these things come together? The picture that you're looking at is event-driven integration. It's already making a huge difference in these domains such as supply chain, order management, logistics, and so on, by creating kind of integration at the edge, right? So these are micro integration or event-driven microservices that can interact with each other in real time using event mesh. We just want to bring in the AI components into the play. It could be an AI-enabled apps, AI agents, LLMs, or vector databases, and so on. So taking in the business events to process and provide context for the RAG and Gen AI. That's the goal here, right? So AI components plays ball with the micro integration that makes up your event-driven ecosystem. Okay. When it comes to use cases, it started out with a kind of serving internal needs, for efficiency, like a code change summarization, code review, support ticket summarization, and so on. And then it also got extended at Solace by using AI for um, external purposes, like micro integration for AI schema mapping and then chat with docs, chatting with your knowledge base, and schema slash code generation, and so on, right? But the vision is to build a framework, right, which will help our customers to build an event-driven AI applications. So it started out with the Solace AI connector, which we'll be discussing in the next few slides, and then leading towards an agentic AI in this agentic AI-based chatbot is a good example, which I will also showcase in a minute, right? And also the goal is to being a cloud company, right? Cloud supported operation. We want to automate the production engineering workflow as well. So that's the vision. We are moving towards that, right? Chat with docs, that's a very good example of how AI kind of enhanced our product usability and presence in front of our customers. It uses various AI kind of systems to interact with all the knowledge sources, starting from documentation, tutorials, and our GitHub code, blogs, and so on, to answer your question. It's just not about the response, but also about the source for further reading and references. Okay, so I'll show that towards the end. And in the real world, it's not just about the chatting with docs kind of style. You have a real scenario, like you have a store manager AI, which takes an input from various components that makes up your enterprise, like inventory, weather, calendar, historical sales data, video feed, and so on, and absorb that as input and passes it down to other agents, specialized and focusing on particular aspects of the business need, demand forecast, incident management, fraud detection, and so on. And eventually, the outcome that's coming out of this store manager AI can be fed to the edge applications like a loyalty app, replenishing stock, or kind of the robots that are operating at the floor level, or staff variables, and so on. And this is where we are moving towards, in terms of AI in the real world. And it comes down to real-time event or other data and context awareness. Okay? Let's take a look at AI with EDA in terms of making the RAG and LLMs easy to understand and work with. Okay, LLMs, they've been around for a while now, and it's useful for tasks like text generation, summarization, and so on. It excel at understanding the context and producing coherent, relevant response. However, the biggest problem is the hallucination, right? Because it lacks real-time context. Then came the RAG, which is retrieval augmented generation. It prevents hallucination by retrieving relevant real-world data from your data sources. It could be internal or external. Enables the AI to fetch up-to-date and proprietary information if needed. That's not included in the training set, right? So RAG also has the ability to point to original sources where the information is retrieved, allowing the users to verify and review that, right? This is a great improvement over the plain operation on a plain trained models, okay? Now, this can be accomplished in an ad hoc manner by writing code or business service and so on. But the approach Solace has taken is to build a framework. The framework is called Solace AI Connector. That's the one that bridges the AI and event-driven systems, right? With this, some of the benefits are real-time event processing, event-driven AI workflows, and integration with the existing infrastructure and so on can be realized for improved decision-making and streamlined development, right? So talking about Solace AI Connector, it is a lightweight tool facilitating integration between models, like our LLMs, and Solace PubSub Plus brokers, basically acting as a bridge for real-time data streams, right? The functionality is to receive events from the PubSub Plus broker in real time, basically consuming events, and build a workflow around that, right? And once the events are retrieved, process these events with AI, including LLMs, RAGs, and others, and send the result back into a PubSub Plus broker by publishing them as events, right? This offers a facility to support dynamic and adaptable AI systems, rather to create dynamic and adaptable AI system that can work with live data. EDA offers scalability as a out-of-the-box facility, and AI ecosystem can benefit from that as well. This is designed, the Solace AI connector is designed to handle increased event loads as applications grow, with options of using multiple components, some including a built-in or the custom ones for flexibility in various use cases. Right? This is an open source connector. I will show the GitHub pages and kind of walk you through some of the configuration and feature set. Okay. Now, diving deep, it has two key flows. The first one is ingestion, preparing the data for use. We're talking about use of RAG here, right? So data comes through Solace, PubSub plus broker, and we embedding the data, basically derive the value information and storing the embeddings in a vector database, right? This is the data ingestion part. Solace AI connector retrieves the events from broker and updates the embeddings in a vector database. And then comes the interaction, answering questions in real time. Basically, that's where the generation comes into picture. Based on the query coming through in the form of events, retrieve information with RAG and generate real-time responses, right? And all these interaction could involve multiple steps, and the steps could be kind of made to work with the Solace capabilities. It could be a plain topic-based interaction, or it could be a persistent queue-based interaction. Right? Now, in the big picture, the Solace AI connector ensures AI-powered applications remain connected with the latest data as it occurs or as it comes through the broker, and support for various data types, including customer interaction, IoT data, and financial transactions. That makes it more powerful. Right? All these AI models enables if, kind of processing and responding to events in real time. Okay, and it integrates with the powerful capabilities of the LLM embeddings, vector database, and the Solace EDA. Right. At this point, let me switch over to the Docs chat and talk about the Solace AI connector tool and a quick demo. Okay. I'm going to switch the screen. All right. So this is the Solace AI connector that we're discussing. It's completely open source framework, and you can find a lot of guides and references how to use this, basically documentation. And I just want to focus on getting started. It's a Python-based framework. It starts with setting up the environment, followed by setting up certain environment variables for connecting with the cloud broker or your local broker, and the OpenAI keys and the model that you want to use. This one is a working example. You should be able to run this on your machine locally. And the interaction is via events. And Solace, the interaction happens through PubSub on a topic. For example, demo/joke/subject is a topic on which you can publish an event, and that event is subscribed by the Solace AI connector flow, and that in turn handles the interaction with LLMs or RAG and so on. And it can also publish an event back to the broker. Um, so in terms of flow configuration, which I will showcase in a minute. Yeah, here's the YAML file that kind of describes the RAG interaction, right? So the data that is received on this topic, demo RAG data, it gets embedded and stored in a Chroma DB, which is running locally. And then any query that comes in via this demo RAG query, it searches the Chroma DB and runs OpenAI to construct a response and publishes back to the Solace using demo RAG query response topic. Yeah. And if you look at this is a shared config describing the Solace broker connectivity. And then you have a flow definition. And it has multiple components. The first one is chroma ingest. So this will be uh, right. So it takes the data input on this topic, and then it hands out the next component, which is a chroma embed. Uh, Basically embeds the data in the chroma DB, and it does certain transformation on the data as it progresses. And RAG inference flow is nothing but a flow that gets triggered when an event is received from the broker on this topic, demo RAG query, and it runs a chroma search component, which kind of searches the database and gets a response and publishes back to the broker. And the topic is, here it is, input topic / response, right? So this is how you build your flow using the custom built-in components, or you can even build your custom components and switch them to create a flow. Okay. Now let me show the Docs chat application that we built with our RAG. So a query issued on this page is going to be against the model, and that kind of interacts with the various data sources like our knowledge base, tutorials, guides, and so on, and gets you a response. For example, I asked what are the known issues with LVQ, right? It asked what version are you talking about, software version, appliance, or cloud, and then it came back with a response and also some relevant sources that may contain additional information. This is useful, right? And then I asked another question: when to use non-exclusive queue versus partition queue? More of checking on the best practices. To answer this, it kind of lists out the capabilities, and then it goes into detailed key considerations. By looking at this, one should be able to get a good idea as to what these features are, or what are these two queues, and then when to use what, and also links to references. This is what the AI can do for interacting with the basically a RAG-based AI, right? So quickly, let me run a demo. So over here, I'm running my Solace AI connector that's built to work with patient data. I know it's hypothetical. The patient data is nothing but now I have this patient information that's loaded with simple text like patient at data at a timestamp, heart rate, BPM, heart rate, blood pressure, blood sugar levels, oxygen saturation, and so on. And it's a timestamp data for all the patients coming in. So this data set is kind of we're going to ingest into the Chroma DB, right? So by okay, let me also run a okay. I'm going to run a receiver. Steam receive. Okay, connected to the broker, and I'm running a receiver to just to show that the event interaction happening both in terms of publish and subscribe. And I have my connector started, and now I'm going to run the send command to kind of initiate the data ingestion. Okay, let's do this. So as you can see, data is ingested, embeddings are created. Now at this stage, what if I issue a query, right? I am querying by publishing an event to ops patient RAG query. Let me show what the patient.json contain. Patient query. So asking a query, analyze the patient's data for anomalies, specifically focusing on patient P002 based on the last two readings on vital. Are there any critical changes that require immediate attention? All right. So I'm going to publish this. Let's see what happens. All right. It's going to run through the flow and then gets a response back to us. Give it a second. Yeah, here it is. I know it's a text one. The last step, it should be converted into a proper JSON and published. Let me show a kind of a result. This is how it looks like. Patient ID P002 and critical changes observed on each of these parameters. And there's also a recommendation. Multiple concerning vital signs that are trending in an unfavorable direction, and so on. Right. So what we're looking at is the kind of interaction between EDA, event-driven architecture, or your event-driven systems that's runs on Solace Plus, and an AI application. Right. This is just a simple example, but using this Solace AI connector framework, one should be able to build more robust and meaningful business cases. Here are some examples. It works with the all LLMs. You can examine these things and kind of find LangChain, mixture of agents, OpenAI chat, Chroma RAG, which is what something that we ran, and Vertex AI, Anthropic chat, and so on. Right? So AI and EDA are a great pair. AI needs real-time context, without which we know the problem. What happens? Hallucination and inaccuracy and referenceability, right? All those things will become serious issues in an enterprise context. With the use of event-driven architecture and event-driven APIs, we should be able to provide this real-time context to make the responses more timely and accurate. Right? Um, that's from my side. Thanks for the time. I hope you enjoyed it. Appreciate it. Thank you.